Okay, good morning. My name is Beres Chitsas. I'm a director in Microsoft Research. By show of hands, how many of you are having a good time in Las Vegas? All right, yeah. How about MIX? Woo! All right, excellent. Okay, I'm going to be talking to you about Microsoft Research. How many of you know that Microsoft had a research division? Great, that's pretty good. You can go down to the casino then. No, I hope I can tell you something new, and you can get a sort of a different perspective on research, Microsoft Research, in this presentation. One of the things that we're all seeing is the rapid change in technology, and this is really one of the drivers in why Microsoft is investing so heavily in research and development. In fact, last year we spent over $7 billion in research and development. That's probably more than any other company. We all see the power of the devices increasing in terms of whether it's graphics, whether it's speed of CPU, whether it's a network technology. We see wireless connectivity, all these new devices coming on board. And actually, all these devices, they're really being very pervasive as well, whether it's in your car, whether it's a watch on your hand, whether in the future it's your microwave oven. I mean, everything is getting smarter. Connectivity with sort of wireless prevalence of wireless technology, all the devices and everything is getting more connected. So people want information everywhere they are, using any device that they have in their hands. And sort of moving forward, when you look at other technologies such as nanotechnology, it really becomes even more pervasive. You could potentially think of displays that could potentially be paint. You could paint a wall with a display. You could think of a pill in healthcare that you could consume, eat the pill, and then depending on where it is and your bodily functions, it can release chemicals in your body to make you perform better. I mean, it's just remarkable when you see all the things that you can do. I was reading somewhere that DARPA is actually putting MEMS technology on insects so they can gather information about the network in environments where humans can't go. So you can really see that technology is getting extremely pervasive everywhere that we are. And this is really important for companies such as Microsoft, such as yourselves, to innovate so that you don't sort of fall behind. When you look at the web, it's just tremendous. Whether you want to write a paper on vision technology, if you want to get information about your competitors, if you want to go buy something, you want to do commerce with another company, if you want to socialize, everything is now on the web. So it's, again, another place that we see that there's tremendous growth, tremendous change. You know, 10 years ago, I don't think anybody could have sort of imagined what's happened to the web today. And that's only 10 years ago. So it's extremely difficult to predict what's going to happen. But you always have to keep that in mind, that things are changing so often, so fast, that you need to innovate and continue to invest in the future. So that's why Microsoft is investing and has invested in the past so much on research and development. We were founded in '91. We have 700 people in Microsoft Research. It's a very open lab in that if you go to research.microsoft.com, you'll see all the research that we're doing. We collaborate a lot with academia. In fact, last year we spent about, I think, 10 to 15% of our budget went into projects outside of Microsoft, working with academia. Last summer, we had 200 PhD students working at Microsoft Research. Just to give you a perspective of what that is, last year, there were about close to 1,000 PhD students in computer science in the entire United States. So if a fifth of the population of the PhD students in the entire US worked at Microsoft Research. We also contribute heavily to the field. We're very active in large conferences such as SIG-IR, which is a information retrieval conference, SIGGRAPH, which is a graphics conference, CHI, it's a human interface, computer-human interface conference. A large number of papers actually came from Microsoft Research. So we're a very open, collaborative research organization. It's kind of like a university within a company. And researchers love being part of Microsoft Research because they can continue to publish papers. The other thing is that we actually contribute heavily to our products. And I'll have some examples of that later on. Over the years, we've contributed maybe dozens, maybe probably over 100 technologies that actually came from Microsoft Research. In some cases, we actually spin a whole group out of research and take it into the product groups. And that happened, for example, with speech technology. The whole idea of tablet came from Microsoft Research. Most recently, the SPOT technology, Smart Personal Object Technology, which is essentially taking the common language runtime essentially and squeeze it down to firmware so that you can integrate it into very small devices such as a watch. And the first instance of that was a watch where you can receive information over RF on your watch. But what's new is that last year we started to try to see how we could broaden our impact. And one of the ways that we thought we could do that was to make our technologies available to commercial companies. And I was very excited to see that happen. Later on in a presentation, I'm going to ask the CEO of INREX, a startup in Seattle, to come and talk to you about a technology that they took from Microsoft Research, and they've built a very successful business out of that, and we're very proud of that. Our labs are across the globe. We have a lab in Beijing, China. We have one in Bangalore, India, and one in Cambridge, UK. And we have one in Silicon Valley, Bay Area. The reason we have one in these different areas is because there's a good concentration of people in those areas, and we want to be close to those communities as well. At any one time, I would say we probably have close to 150 projects going on in Microsoft Research. And if I was going to take these 150 research projects and sort of put it into buckets, these are the big buckets that they would come under. And you can think of these as sort of the big bets that Microsoft's making in the future. We want to make sure that we make computers accessible and these smart devices accessible to more people globally. Whether it's you interacting with your mobile device, it's still extremely difficult to get content on a mobile device, to interact with a mobile device using sort of natural language and speech technology. We want to make that easier. In terms of the information overload, there's just so much information out there, and when you look at storage technology, in the next 3 years, you're probably going to have a terabyte of storage on your laptop. Now, on a terabyte, you can actually store everything you say in an entire lifetime. So that could potentially be your digital memory. And when you look at that, and that's just on your laptop. Now, when you look at the internet, you look at the information that's in your enterprise, all the information that's on the edge of the network, there's just a huge amount of information that you want to be able to organize, you want to be able to manage on a back end, get backups, make sure they get retrieved, you get the right relevant information back, and so on. So we're doing a lot of work in that space. In terms of collaboration, there's several different angles here, whether it's in the enterprise, doing real-time collaboration, distributed meetings, whether it's on the web, social networking and communities on the web. We're investing heavily in that space as well. I mentioned mobility being a big theme and a big trend. We're doing a lot of work in that space. There's a lot of challenges in that space as well. Media and entertainment with digital convergence. I mean, we're going to have our videos, we're going to have our music. We're already sort of getting more and more of that on the internet and in digital form. So being able to retrieve that information, being able to edit it, get it on different types of devices, all of this are work that we're doing. Also, another aspect of that is generate 3D graphics. So when you look at the power of GPUs, they're actually increasing faster than Moore's law. You can imagine that in the next 3 to 5 years, you can generate reality on PCs. Even today, you look at Xbox 360, they do a pretty damn good job of doing that. Software development, that's probably the most impactful. When you look at what's happening, people aren't going to store their information on the internet or on their PCs if they're not going to be if it's not going to be reliable, if it's not going to be secure, if it's not going to be performant. So we're investing very heavily on tools that will enable software developers to develop software more robustly, more performant, and so on. So there's a lot of work that we're doing in that space. That sort of fits in very well with sort of trustworthy computing. In terms of hardware, we actually have a hardware lab. Sometimes you need hardware to take advantage of the software that you're building, and we've done that several times. A lot of times what we do is we actually create a first prototype, then we take it to hardware vendors, and then they actually produce the hardware. So that happened with the tablet PC. That's happened also with a Spot watch that I mentioned. The first Spot watch that we created was essentially on a firm board about this big. And we take that to vendors such as Fossil and so on, and they make the watches. We're also investing very heavily on human-computer interaction, pointing devices, such as, or interacting with gestures. When you think about very large displays, how are you going to interact with that space? So we're doing a lot of work in those areas as well. How many of you saw Minority Report? Okay, we actually have that working on Windows, so you can move windows around with your hand and stuff. Now, I mentioned contributions to product groups. These are just some of the contributions that we've had. Over the years, we've had many, many contributions. I mean, anything from the grammar checker in Word that appeared in Word 98 to a bunch of technologies that have actually gone into Windows Vista and are going into Office 12. And that's sort of the part of taking ideas and turning them into reality. So we turn them into reality in our own products. And as I mentioned, we've started to do that through other companies as well. And we want to see more of that. What I was going to do is sort of give you a taste of some of the work that we're doing in these different areas. In terms of mobility, we're investing very heavily in this space. And there are quite a lot of challenges here. When you look at all these different network types that are going to be available, GPRS, Wi-Fi, and being able to Bluetooth, and being able to get information across all these different networks, having constant connectivity, having devices that are really smart. When you look at, for example, battery power, that's not increasing. That's not on Moore's law. So how can you make devices that are smart? And again, software is what enables all of that. How do you make devices that are smart so that they can turn the radios off and on when it's required, so that they don't use too much power? In terms of the fact that people are going to have so many different types of devices, how do you make information available to them on their device so that it's more appropriate for that device? Adapting technology, adapting content to the different devices, making it easy for them to interact with that content and interact with the machine that they're using. And also, what are some of the services that are interesting? Location-based services. When I can move things around, I should be able to say, print to the nearest printer. When I print, I don't have to go and configure things. I should be able to just do that. And it should be able to point me to the nearest printer and tell me where that is. So there's a lot of things related to that, whether it's advertising, whether it's when I'm here, for example, I should be able to bring my, using my Pocket PC to be able to control my, this presentation here. Maybe my notes should actually appear on the Pocket PC, and then I have the presentation up there. So having these devices actually interact with each other. So we're getting into this sort of disaggregated computing where you have these devices and you want them to work well with each other. When I take my Pocket PC and I dock it beside my workstation, it should be able to extend my workstation automatically because I've now got an extra space there. So having these devices be able to work with each other is also very important. One of the technologies that we've been working on is this idea of sort of adaptive user interface. How do you make it easy for a mobile device to navigate a website? So what we do is using the structure of the website and the content, we take the website, essentially scrunch it up, color code it so that you can easily navigate through the website, and it's much easier than having to sort of scroll back and forth on that page. This is it's pretty mature technology at this stage. Another one is taking media. How do you browse media more efficiently on a mobile device? So using digital imaging, being able to find out where the interesting portions of the image are and focusing on that section. So we can do face detection. We use sort of color and contrast to determine where the interesting part of that photo is and focusing on that. So it gives you a much better result when you're viewing it on a mobile device. Another technology that we've been working on, that we worked on, was essentially taking Bayesian methods and applying them to traffic. And this is turned out to be a very successful technology transfer to INRIX. And I'm going to actually ask CEO of INRIX, Brian Mistally, to come up and tell you a bit more about that. Hi, Brian.
Great, thank you.
Thanks.
Well, thank you. I'm glad to be here. Let me take you out of the world of research and APIs and everything else you're learning about in MIX and take you to the world of traffic, not internet traffic, automotive traffic. And let me talk a little bit about the relationship we've had with Microsoft Research. If any of you are familiar with the world of traffic information, you'll know that it's actually quite poor compared to other types of information, say stock information or weather or news. It's actually less mature. And if you look at the history and the evolution, there's been this change from historically what's called incident data. This is the stuff you get on AM radio in the morning that says that there's a crash at a certain exit on a certain freeway. Well, that's kind of interesting, but it's not terribly useful, is it? I mean, it's nice to know there's a crash, but it'd be better to know, should I reroute around it? How long is it going to take me to get through it? That type of thing. So there's been a lot of focus on what's called flow information, or knowing how fast cars are going at any given point in time. And several cities now have sensors in the roads built out to detect real-time flow. The problem with real-time flow is, quite frankly, you don't care what traffic is like on I-15 right now outside of Las Vegas, do you? Because you're sitting here in a room listening to me talk. What you care about, what I care about, is my flight today is at 2:30. What time do I have to leave the conference to get to where I'm supposed to go? If there's an accident, should I reroute around it? What's the best way to reroute around it? How long will it take me to get through it? Applications like send me an alert if my commute in the morning is going to be more than, say, 10 minutes outside of its normal time. That type of information is very personally relevant, and that's what INRIX was really founded to address. But let me tell you a story. We started this company in Seattle, and we started focusing on this technology. And the idea really for the core of our technology came out of left field, literally. I was at a soccer game with my boys Saturday morning, and I ran into somebody from Microsoft Research. And I was telling him a little bit about what INRIX was up to. And he said, well, that's interesting, because Microsoft Research has spent the last 3 years developing technology around traffic prediction and being able to very accurately predict traffic into the future. And we'd be very interested in licensing that to INRIX. Now, if you're me, you're sitting there saying, let me think about this. Bill Gates spent millions of dollars developing technology in the research labs. They spent years developing it, and they're going to license that to a third party. And the answer was yes. Microsoft Research is absolutely in the business of taking technology that it develops and licensing that out to third parties. And that's formed the core of basically what INRIX does today. We take data feeds, literally 200 different data feeds, and aggregate literally more than 20 terabytes of data. Data such as historical traffic patterns, incident data, construction data, but also a variety of other data, including things like school schedules and weather forecasts, and a variety of other variables that influence traffic. And then we run that through this Bayesian statistical analysis engine. And then we provide as data out to application developers. INRIX is in the business of selling data to websites, to in-car device makers, to mobile application developers, who basically can take this and build it into their applications. And that's what we do. So how does it work? Quite simply, the Microsoft technology, which was developed, as we've come to discover, by 5 of the top Bayesian scientists in the world, literally takes a variety of variables, like I said, things like weather conditions, sporting events, as well as school schedules, and creates what's called a dynamic, real-time Bayesian network analysis of a city, so that it knows if there's an accident, how long it'll take for that accident to clear. It'll do prediction on how fast your commute will be in the morning. As you can imagine, your commute really is a function of a variety of different variables. I don't know how many of you know this, but school schedules in most markets turn out to be the biggest significant contributor to traffic. And my commute actually varies from 45 minutes down to 20 minutes, depending upon when schools are in session in Seattle. And naturally, when there's concerts or sporting events or other things, that impacts traffic as well. So INRIX, based on this technology from Microsoft Research, really created a whole new business. Now we're one of the leading providers of traffic information in the country. And we provide real-time data in more than 137 markets today. We provide predictive data right now in more than 16 markets, and soon to deploy nationwide on every single road in the United States. We will have predictive traffic information available. But 2 other side effects of working with Microsoft Research. This technology has enabled us to dramatically improve the accuracy of traffic information. Being able to basically take road sensor data, which is inherently inaccurate. About 20% of the road sensors are actually miscalibrated at any given time. So imagine if you were building a stock quote application where 20% of the data you get from NASDAQ is wrong. Well, that's what happens in the traffic space. And we're able, because we know it should be happening, we're able to actually correct that in real time and produce much higher quality traffic data. And we're also obviously able to expand to much broader coverage. We actually take data from road sensors, GPS devices, and now cellular devices, mix it together through our Bayesian models to produce high quality traffic information. And obviously working with Microsoft has its benefits. If any of you work at a startup, you know that getting any press attention is difficult. And rising above the clutter of all the startups out there is not easy. Well, because of our relationship with Microsoft, we've been able to basically go out and get enormous amounts of press. Microsoft has been extremely helpful in talking about this technology, talking about the benefits. And it's enabled us to literally get press, hundreds and hundreds and hundreds of articles, TV, radio, that we never would have been able to get without our relationship with Microsoft. So let me give you an example. I'll actually walk you through. No, you may have to help me here. There we go. So this is actually real-time data in Seattle. This is an application that we put together to highlight the technology and obviously the real-time data that we have. So what you see here is obviously a standard map of Seattle. The major freeways, obviously the red, green, yellow, black, shows you current states of traffic in Seattle. And I can go in here and I can overlay incidents and do things like that. But the really cool part is I can actually go forward at any point in time and see how traffic will change. So as I go forward, obviously into the day, traffic is actually what you would expect. And as I go into, say, the evening, you get more and more congestion. So we're able literally every 15 minutes, every hour, every day, up to a year ahead of time, predict what those traffic conditions will look like. And if you can see over here on the left, we show you for a variety of key routes, Seattle to Bellevue, Seattle to the airport, how long it'll take you to get there. So if I need to know my plane lands today at, let's say, 5:45, it's going to take me about 62 minutes to get from the airport up to Redmond. But we also do some interesting things around short-term prediction. So this shows you that there's currently congestion on the bridge right now, the 520 bridge in Seattle, but that clock, that circle, is basically saying that that congestion will clear up in 15 minutes. So we're able to very easily say when traffic will congest and when it'll clear up. If you're like me, most days you have to take the same route to work. So what you really care about is if traffic is better or worse than normal. And we're actually able to show you, relative to normal, is traffic better or worse? And if you're a real geek like me, what you care about is how long is it going to take me to get home if I leave at 5 o'clock, 5:30, 6 o'clock, 6:30? Should I wait an extra half an hour? And in some cases, I can actually get home sooner. So we're able to also show that type of information. How do I switch back? So, why am I here? It's really two reasons. Number one, I'm here to basically tell you that Microsoft Research is in the business of licensing technology. Think of it as a store, and you can literally go to their website and they list out more than 50 different technologies they have available for licensing to third parties. And that's actually pretty cool, and obviously allowed us to basically take advantage of their years of research and millions of dollars of investment. But also, I can't resist, I'm at a developer conference for Microsoft. If you're interested in traffic data to basically build a sidebar app or your website or your mobile device or whatever it is you may work on, I'd love to talk to you about taking advantage of traffic data. We provide it in standard XML format using file transfer over HTTP. We provide real-time flow, real-time incident data, predictive forecasting data, and we code it to all the map standards, Navtec, TeleAtlas, TMC codes, and a variety of other formats. So if you're interested in potentially incorporating traffic data, just go to dev.inrix.com, and we'd love to talk to you. Thank you.
Thank you, Brian. Yes, we will have at the end. Oh, is that okay? Yeah, you can, yeah. I'll make sure he's up here. So we are just so proud, very proud of what INRIX has done and how quickly they actually turned something, an idea, into a service and into a company, essentially. It's just super exciting to see that. So we're in Las Vegas. So we got to talk about media and entertainment, right? And I wanted to share with you some of the work that we're doing in this space. There's a lot of different projects that we have in this space, whether it's related to speech indexing, searching for video content, summarizing video, essentially making video and media a first-class citizen, just like text is, being able to search that and find information that's relevant. But we're also working in the area of 3D modeling, as I mentioned, dealing with sort of games type of technology, so we're doing a lot of work in that space as well. And also interactive video. One of the issues with video today is that it's really not interactive. You sit back and you sort of watch it, but sometimes you want to being able to sort of interact with that is an interesting thing that we want to sort of work on. So I wanted to show you a demo of a work that we're doing related to interactive videos. Okay, how many of you have seen sort of 360-degree pictures like iPics, where you sort of go around and you can go around and sit? Think of this as essentially 360-degree pictures on steroids. So the idea here is that you can actually walk through an environment, capture that environment using a 360-degree camera, and be able to later on go and interact with it and move throughout the environment in an interactive way. So that's essentially what we've done here. This is actually a nice house of one of the Microsoft VPs. So what we're going to do is we're going to walk through this house here. There's a lot of sort of research technology that's enabled us to be able to do this. So this is Dan Ling, actually a VP of Microsoft Research. And the way that this has been created is that someone's actually walked through this environment with a 360-degree camera. And what the technology does is it actually captures all this information, and it stitches everything together. It deals with the lighting exposure. So it does high dynamic range enhancements so that you can actually see things which are exposed at different light levels. So you can actually see things which are outside as well as inside. So I can just move around this space, and you'll notice that you get information on the top. So there's an authoring tool that allows you to actually go ahead and sort of put information about the space. So you can see that this is kind of something that you can use, whether it's in real estate, tourism, or a lot of sort of spaces like that. You can use this technology. Thank you. Okay. The other demo that I wanted to show you is called Video Textures. And the idea about video textures is essentially to take a very small clip of video and reorganize the clips in such a way that you can loop it around, and it sort of appears as if it's a running video. It's a constantly running video. And yet it's like this video that I'm showing you right now, for example, is, now isn't this the coolest sort of background here? It's essentially probably about 15 seconds to 20 seconds of video that we've rearranged the frames in such a way that it sort of appears as if it's a constantly running video. You can clearly take this and embed it inside websites to make them more interesting. Great, thank you. All right. I just thought I'd choose, a few things, but we have a lot of technologies in this space that we're working on. Another area, as I mentioned, that we're working on is dealing with how do you categorize, how do you find information. You should be able to say, find me the photos in my album that have me and my wife in Las Vegas. So it should be able to go and find those pictures, or find me pictures which are similar to this other picture. So being able to identify people, being able to find images which are similar to other images. Now, this is not from a security perspective. So we're not doing we're not saying that this is good enough for security. It's really mainly for organizing photos and stuff. It's very easy humans are much better at recognizing people as they sort of change than machines. It's going to take a very long time before machines can replace that. But it's good enough for us to be able to determine whether there are faces in an image or not, so that you can actually categorize things that way. Also being able to recognize objects. And what I mean by dead bits to live bits, I should be able to take my webcam or my cell phone camera, point it at a magazine or something, and get an online version of that. So I should be able to do things like that. Another area which is very interesting is the area of collaboration, whether it's doing real-time collaboration, video conferencing in an enterprise, or in terms of social computing. We know that there's a lot of people who are contributing to the web, and how can you make use of that, whether it's to find information that you need or find other information, relevant information based on what others like. What makes an online community a successful community? Those are the kinds of things that we're doing in this space. One of the areas that we work on a lot is email. We're all getting so much email out there, and how do you find the emails, or how do you prioritize emails? Snarf is a technology that allows you to prioritize email based on the relationship that you have with people, rather than how many unread messages you have from them or who it's from. So it uses the organizational structure. It uses how much interaction you've had with that person, how many emails they've sent to you, how many people were actually on the to line, whether it was to a distribution list or not. All of this information is used to determine the priority of the email. And we find that is very exciting it's very useful for people. This is actually a tool that you can, in fact, download from research.microsoft.com. If you go to the download site, you can actually download Snarf and play around with it. Another thing that's really important is the idea of visualization. So how do you visualize things? In this particular case, we're actually visualizing somebody's inbox, finding out how much email they've received from different domains and how much that has changed. But we have a number of different visualization techniques, and this is also a toolkit that's up there on research.microsoft.com. So there are many different visualization techniques that you can use for different needs. The one on the right bottom corner is called Tree Map. And the way that this helps is to determine the trends in data. Sometimes it's not a matter of graphing, for example, how large a community is, but it's like how much has that community changed. So the idea here is that the colors represent the changes in a community. The size is the size of the community. And red indicates that the community is changing. The number of posts to that community has decreased in the past month. So you can very easily determine which communities are more healthy and which ones are more active than others. And there may be reasons why some are dropping. For example, when you make a release, right at the beginning of the release, the community is extremely active. Over time, it becomes less active. So you can very easily visualize that. In fact, we do that to help us with support, to determine which communities are more active than others, and help us to make predictions on what support is required for different communities, for different products. And as I mentioned, there's many different ways of visualizing things and visualization techniques, and we have a toolkit that allows you to do this. One of the things that our social computing people are good at is coming up with abbreviations. So Mo, so, SLAM, Aura, they're really good at these things. They hang out in social, so they're very social, so they know what is socially acceptable, acronyms. So I wanted to talk about two other projects. One is called SLAM. And SLAM, the idea of SLAM is integrating social communities with mobility. How do you sort of pull these things together? How do I create a group and distribute information, media information across that group easily, annotate things that other people have said? It also integrates with SMS, let's say, the most basic form of communication on cell phones. How do you create communities of SMS users and share information with them? But in this particular case, SLAM is about sort of multimedia, rich devices, and being able to create groups and being able to share information across them. Aura is about taking the physical world and integrating it with the cyber world. Sometimes there's a lot of information that's available in cyberspace. And if you're out there in the physical world, you want to be able to hook the two together. And the idea of Aura is just that. How do I do that? What I'm going to do is show you a video of Mark Smith, who heads this communities group, and he'll be talking about the Aura project.
object has a story to tell, and some of those stories are, well, pretty important. If you look out at the range of physical objects that surround us, you'll find that almost everything has something else that you'd like to know about it. And if you look at the labels on things, you'll find that in many cases they only show part of the story. The problem is bringing that information to the physical object at the time and the place that you need that information. Using the Aura system, we've outfitted a mobile computer with a machine-readable tag reader. Take your cell phone and any physical object, point the phone at the object, and scan. This connects you to the community of users or other consumers of this product. Take, for example, you're shopping for a video game. You might not know which video game to buy, and using Aura, you could click on them all and plug into the community of users who use those games, who play those games. And you might find out which of the various games most suit your interests. It's possible to use Aura to click on an object and add your own opinions and information to that object and make those annotations findable by other people who also use the Aura system. Everybody would have a new way to express their voice, to say what they think about the objects that they find important in their lives. And not just to express it, but to be heard by others who also share an interest in those physical objects. Not every choice we make in a store is trivial. Sometimes we make choices that are very consequential. For example, when we're choosing foods to eat that may have medical or dietary implications for us, using Aura, we can actually investigate whether or not these are foods that are good for us or foods that actually comply with our medical regimes. This is going to mean that a conversation is going to emerge. A conversation around every physical thing among every person who cares about that thing. Shopping is, in many ways, a social process. People like to shop together, but they can't always be together. Using Aura, when you go shopping, essentially you're with everybody who has ever shopped for that object before. It's about connecting people to people through the things that they both share as important in their lives.
Great. Thank you. So this is about sort of pulling together essentially information that's in cyberspace and really integrating the two, right? The real physical world and the cyberspace world. Moving into the future, you know, you're going to have RFIDs on nearly every single object that you can imagine. And being able to, and devices in the future could potentially have sort of RFID readers. So being able to sort of get close to them and get information about that, share information about your likings and other people's, and getting collaborative information about what other people like, you know, those things are going to become more and more into the future. So as Mark mentioned, there's going to be Aura portal. In fact, if you go to aura.research.microsoft.com, the site is actually active. Right now, I don't think you can go and sort of contribute to it, but it's active, so you can see some of the people are, it's in pilot stage, so people are putting information up there, so you can search that. The other part of this is actually, as I mentioned, is what makes a healthy community? What are the things that you want to expose in your community so that people come back and it becomes sticky? And those are some of the things that Mark is working on as well. Now, I've been mentioning research.microsoft.com. And what I wanted to do was to go and sort of show you essentially our research site. So this is our research site. How many of you have actually visited research.microsoft.com? Oh, wow. Terrific. You can definitely go back to the casino. All right. So one of the cool things about research.microsoft.com is a download site. So there's a lot of really cool tools and stuff. Some of the things that I mentioned, for example, Snarf is down there. We have some really interesting, over here we sort of, on a regular basis, we update this section and we mention what are some of the popular download sites that we want you to, that are interesting for people to go and have a look at. But if I go to the download site, it's organized alphabetically, and we're working on sort of changing this. Clearly, it's not very usable. Research should be able to do better than that, right? So this is an area that we're going to be making it sort of more, sort of categorize it in a better way. But you can go here and sort of download different sort of tools and stuff. How many of you have actually tried things out on research on the download site? Great. Okay. That was kind of what I had. Now, I know that we're sort of a little bit early, so we have quite a lot of time for questions. In terms of sort of, it seems like a fair number of you have already sort of visited research.microsoft.com, but I know that there's a bunch of questions, so what I'm going to do is just stop here and just let you shoot away. Brian, would you like to join me? Great, thank you very much.
It was a fascinating presentation, though. Thank you. I had a question about the service you offered. Was there any practical applications of mashups as far as mapping applications? They always give you the directions, then tell you basically how long it'll take you to get there, and those are probably in the low traffic conditions. I would assume best case scenarios. So if you could input the time that you'll be leaving, there's an opportunity there, I think, to improve those numbers. Have you seen anything like that shake out of this?
No, you're absolutely right. I mean, if you think about the applications for predictive traffic, it runs the gamut from various web-based applications and mobile applications, automotive, fleet, logistics, even public sector. We provide data, and we're actually working with now more than 24 different firms building those type of applications. And let me just give you 3 examples. One company is working on a display inside a car to basically tell you how long your commute will be in the morning. So you go to a website, you tell it your home address, your work address, you get in your car in the morning and it says 37 minutes to work. Most applications are focused on basically rerouting or time estimation. So what's the quickest way for me to get from, say, LaGuardia Airport to downtown Manhattan at any given time? So when you book, for instance, your plane flight, it'll also give you a map of how long and how you should get there. So there's a whole variety of applications around predictive technology, and it's really up to the imagination of application developers to take advantage of the data we provide and build those applications.
Thanks.
Hi there. A question for you about more on the lines of HCI and data visualization. So you touched briefly upon the Minority Report, and I think your words were, we have Minority Report working with Windows. But it's been said that data visualization and information visualization is really ripe for revolution and not evolution. So, looking at the name of the operating system, Windows, do you really see any revolution happening with visualization, or did Xerox get it right decades ago with the Windows metaphor?
Yeah, so we're doing some sort of real future work in that space as well. For example, we have this project where we have sort of sensors that you put on your, essentially it's like a helmet basically, but it can potentially be very, very small. That sort of senses blood flow into, it's like an IR receiver that sort of senses blood flow into your brain. And based on that, it can determine whether you're getting overloaded with information or not. And we can use that in order to determine whether a user interface is working for you or is not working for you. So there's 2 ways that you can use that. One is that in cases where you're dealing with huge amounts of data, the user interface can adapt to your physiological senses. The other part is that we can actually use that to experiment and do user studies to determine how well a user interface works. And then, as you mentioned, there's just so many different ways of dealing with user interfaces. 3D, we've worked on 3-dimensional desktops. I can actually show that. You know, there's a lot of work that we're doing in that space as well.
I'm wondering, even with all the resources that Microsoft has invested in research, what sort of selection process and idea criterion process and selection you go through to decide what areas to invest your resources and time of your resources in for research projects?
Mm-hmm. So what we do, there's two things that determine that. One is the trends that we see, social trends, technology trends, industry trends. So that's really important to determine where do we invest into the future. The other thing is when we see somebody who is in a certain space and is very well known in that space, then we get into that space. So for example, an example of that is graphics area. We wanted to get in the area of graphics, but we usually get into a brand new area only when we see that there's somebody who can actually lead that space. And in that particular case was Jim Blinn, who's very well known in the graphics field. So there's two ways that we do that. One is sort of the main part of it is really looking at all the trends that are coming. For example, one of the trends that we see is multi-core. And dealing with multi-core is going to be very interesting because in the past, we've always depended on CPUs becoming faster and faster. Now, instead of becoming faster and faster, you're now going to have more of them running at the same speed. Concurrency becomes extremely important. What are the applications that can make use of that? What are the tools that you use in order to build applications for that? And it's very hard for developers right now, tools to deal with sort of concurrency. So we're investing in that space because we see the trend there.
And I guess just one quick follow-up tactically. So you identify a space, and then do the individual researchers or the directors of those specific spaces submit ideas or go through some sort of evaluation process for, you know, specific tactical areas to research? I mean, how does that happen?
What we do is there's very little directed research. So there's very little sort of managed research where we say this is an area that we'd like you to research in. Okay. It's always a matter of what the researcher, what their interests are, and given that Microsoft is working on so many different, it has such a broad set of products, whether you're in the graphics area, whether you're in natural language area, whether you're in security, there's always a place where it sort of fits in. So we leave that completely to the researcher to determine what areas they're interested in and the fields they want to sort of continue to work in.
Okay, thank you.
Great, thank you.
Okay, I had two main questions. One was recently there was a project called Accelerator.
Yes.
When is that going to be out for general use beyond just the tech report? And what other work are you guys doing with the GPU kind of stuff?
Right.
And then my second question is, are you guys doing any kind of research into like simultaneous multi-user on a single box?
Okay, you're really tracking us very carefully. So the Accelerator project is about essentially taking the power of the GPU and making that visible as like a coprocessor essentially, because there's just so much power in that GPU. Being able to sort of parallelize, anything that's dealing with a lot of sort of data, you'll be able to use the GPU in order to do that, but providing the tools and the language, extending the language so that you can make use of that. Just for other folks here. I can't say, one of the things about research is that you can't sort of say what's the timeline when, we're not very good at it with products, so I'm certainly not going to say when the research is going to come out. So, so in terms of, I won't be able to say at what point. But I think the main thing about that, and I think you're bringing that up, is that we are an open research lab. So it's not like we kept that secret, working on this project, and didn't sort of demonstrate that we're working on it and write papers and stuff. We've written papers, other people can extend that, and we're actively working on it so that we integrate it into our languages so that you can make use of GPUs. And your second question was related to multiple people on a single box. In fact, we're doing quite a lot of work in that space in our India lab, where, for example, for education purposes, we have like multiple mouse and having sort of multiple children be able to utilize a software. The other part there is how do you make software so that illiterate people can actually make use of that as well. So we're doing a lot of work in that space in our India lab.
Okay.
Thank you.
Hi, I have a couple related questions. I run a conference, and how and with who would I engage if I think it's something that would be of interest to Microsoft? It's a conference on networks, including social networks, and in the Bay Area.
I actually, related to social networks, what I would do is send email to Mark Smith. So what I could do is, why don't you after this session just come and
But the general question was, how do you discover from the outside who to engage with?
Okay.
And then the other related question is, if you, like myself, have research that you've done, but is itself sitting on a shelf, does Microsoft ever collaborate with companies that have research that's stagnant and collaborate that might inform things you're working on and vice versa?
Mm-hmm. Yeah, we do have a group that actually deals with that as well. But in general, if you want to find out who to talk to, if you have something, the best place to start is research.microsoft.com. So you can go there, the area that you're in, find out the group manager, and just send email to them. As I mentioned, we're a very open research lab. You can sort of start that way. That's a good start.
Hi, I have two questions that actually comes more from a business perspective. So first, it's amazing to see how many things that you guys are doing over there. I know some of the companies actually set their research budget to a fixed percentage of the annual revenue. I'm just wondering whether that's the same case in Microsoft. And also the second question is, in one of the slides, you showed how many ideas that actually you guys were able to turn into reality or products or services. But I was just wondering, do you guys actually calculate some kind of ROI, or that's not really important? Mm-hmm. Thank you.
That's okay. So you're absolutely right. Some research labs in organizations have to demonstrate ROI, or they have to, in fact, go on from the product groups, they get budget for the research, to perform research. Microsoft Research isn't like that. Bill just loves research. He knows he has to invest in the future. He knows how rapidly things are changing. So it's very important for us to look 5+ years out. And I didn't mention some of the other technologies that we're working on, which is just way out, like quantum computing. We're working in these spaces as well. But there's always a budget, but our budget is fairly flexible, and it comes from the top. We have a very flat organization. From the researcher up to Bill Gates, it's probably 4 levels. So it's very flat, and the budget comes directly to Microsoft Research. We don't have to go to a product group to get research budget, because we think that that's not the way to do it. We really need to think completely outside the box. And if we're going to really tie ourselves to products, then we don't think we can have that flexibility to do that.
Hi, you triggered a question with a couple of remarks you made. Are you also doing research in the social aspects of your discoveries? So the simple thing would be, if everyone would use the services that the company offers, your models would be totally screwed up because people are driving differently. It would be kind of a technical issue. But then you mentioned RFID, which has a huge social impact in privacy and all that. And so are you engaging in research like that?
Absolutely. And one of the things about Microsoft Research is that it's interdisciplinary. So we do have sociologists, like Mark Smith. In fact, his background is in computer science. He's in fact a sociologist, and he's very much interested in the social or sort of privacy, all of these aspects that relate to technology, the fact that it's getting so pervasive. How does that mean? How does that affect our lives? When I mentioned this thing about digital memory, we're in fact working on this device that you wear, and it has sensors inside it, and as you walk around, depending on changes in the environment, what it does is it captures an image. So you can really create a digital memory of yourself. But what are the privacy issues of that? So we are working on issues related to those things as well, and doing a lot of user studies to see what are the things that people, what data are people sharing? What data are they comfortable sharing? How much data do you need to be able to identify a person? All of this stuff is very important for us. Also, how do you sort of fudge data? A lot of people want to be able to use the data, but how do you fudge it so that you can't identify a certain person? So we're doing research on those spaces as well.
Thank you.
Any more questions? Okay. Thank you very much.